Okay. Very good evening to all. Very good evening, guys. Tell me whether my audio video is clear to you. Tell me that whether the audio video is clear. If it is clear, then please let me know. Very good evening. Very good evening. Hello. Okay. So let's wait for 2 minutes and then we are going to start. I think many of you have joined the batch, the Telegram group. Those who haven't joined, please join it as soon as possible. Yeah. Just search Pankaj Sir PW. You will find the batch. You will find the batch Pankaj Sir PW. Just waiting for 1 minute and then we are. Why didn't came? Many of you, many students joined the batch this last 2 days. Guys, those who joined, please helps the other also. Those who joined, please helps the other also. Pankaj Sir _ PW. Yes. Okay, fine. So guys, in the last class, what we have covered, let's start the class. What we have covered is that we have just introduced the subject, its syllabus and its books, and the strategy that I feel from the last 15 years. I have given you a little bit. As the time goes, I will more dwell into it and I will give you the straightforward path throughout the whole nothing but my batch. As far as this control system is concerned, we have just stated the definition of systems and what do you mean by system and what do you mean by control system. And with the promise that I will start the basics from today onwards, that is from yesterday onwards. Yesterday it was not happened because of internet issue. Very heavy rain is going on here in my city, so that's why I think because of that there was internet issue and hence class didn't conduct it. But from today onwards we are going to cover the basic part, the fundamental part which is required for your signal system, control system. So we will not enters into that is a control system, signal system in very rigorous manner, because that's a very comprehensive course of nearly 120 hours. More than that, okay, I have just completed signal system in one of the batch, so it comes around nearly last 2 classes is still pending. So what I am saying is that it's nearly more than 120 hours, but we will take a glimpse. Good evening beta. We will take a glimpse of some, that is a concept which is required for your complete control system. Signal system is separate course. You will see this as the time progress. So I will take you a few very important topics, especially topics from Laplace transform, and especially the part that is the required for your control system, like what is the linearity, time invariance, causal systems, unstable system, stable system, these kind of things we will cover. So let's start from this fundamental part, and the fundamental part comprises nearly more than 12 to 40 hours. That's rough total part we have to cover. So you do not have to worry about the syllabus, because syllabus will going to be end by 30th of October. So by 30th October, definitely your control system will be in your hand, and you will feel the difference that what you have earlier and what you have after taking the course. That's my promise to you. Okay, let's start now. So today we are going to cover some basics of signal system and some basics of Laplace transform if time permits. Okay guys, please tell me that whether if everything is clear, then please let me know that everything is clear from my side, your side, and we are ready to start the class. So just type C. Just type C so that it gives me a clear-cut indication that yes, it's okay. And now we are going to start this. Just type C. C, please. Just type C. Clear? Okay, fine. Let's start now. Everyone, please comment. And that's a humble request, please. Please be participative in the class. If you want a real, that is a essence of the subject, then be participative. Ask as many doubts as you can. And I will try to clear each and every doubt. Is it clear? Let's start now. So see here. Now, before we enter into this subject, let us talk about some basics. And first basics that I am going to cover is this one. See here is a basics of elementary signals. So you may write along with me, or if you want for notes, then you will download the notes also. If you don't want to write, then it's okay. Just download the notes. Whatever I have, I will write in a, that is a printable format. So you can just download the notes. Nearly 20-25 pages notes it is. Basic of elementary signals. And in bracket we will say that these are the test input. Test input for a control system. Let's talk one by one. That is what do you mean by test input? That we when we want to check the that is the performance of a particular control system, then we entered these inputs into it. That's what the meaning of test input. So let's do it. What do you mean by the word elementary first of all? Can anyone tell me what do you mean by elementary signal? What is the elementary? What is the meaning of elementary? Come on everyone. Anyone can tell me what do you mean by elementary part? What is the elementary? What do you mean by elementary signal? Hello. What is the elementary part? Elementary signals are those signals from which higher order signals can be derived. So elementary signals are those signals from which we can derive the higher order signals. Yes or no? So higher order signals means that suppose we want to design a step function. Suppose we want to design this kind of function. This kind of function like this. Let me give you one example. Like say this kind of functions. Okay. Or we want to design let's say a triangle, for example, this kind of functions. Okay. So both the signals, see here, both the signals are made up of some elementary signals. Elementary signals means that basic signals from which we can generate these kind of signals. Is it clear? So when I talk about the elementary meaning is that it is the fundamental part. It's the fundamental signals. Is it clear? So let's talk about the fundamental. How many fundamental signals we have? See, in total we have, listen carefully. In total we have 5 fundamental signals. And let's talk about one by one, which is required for your control system. And one more we will see. The first part is the step function. So this is the step function. First is, second is very important, impulse function. Impulse function. Third is a ramp function. Ramp function. Fourth is a parabolic function. Parabolic function. Now mind it that, listen carefully. These are the functions which is required to test the input. In time domain, in frequency domain, there is another signal we have to take care of, which is the sinusoidal signals. So this is a sinusoids. So we will talk about sinusoids also. Sinusoids means that sin theta cos theta, these kind of signals. If the claim is that if you know the performance of these signals, then any random, this is the control system, any random signal if you enters into the control system, then you can break that random signals into these signals. So the meaning is that they are elementary in nature. For example, by the help of step function, those who have taken the course of signals, you know that by the help of the step function, I can make this function. By the help of ramp function, I can make this function also. So in general, any random signals can be broken into elementary signals or fundamental signals. So I will not take a fundamental signal in detail. Whatever is required in my course, I will tell you as a fact. Please take it as a, because for that I have a separate course which is signal system, and you will see the signal system. Some faculties, or let us say that for the sake of teaching of the subject, maybe I will teach you the signal system. Okay, in signal system we will cover these kind of things, but the point is that I will give you the fact which is required for my control system. Is it clear? Mind it that you are here for control system, not for signal system. So whatever 12 hour I am giving you, take it as a fact. If you don't know, if you know, then it's very well, it's okay. You understand my point or not? Guys, please say why. Because we are not here for signal system. Is it clear? Take it as a fact. Whatever is required, take it as a fact. Okay? And if you know, then it's a very well, it's okay, fine. It's just a refreshing of signal system. Hello? Please give a confirmation on that. Please give a confirmation that this is the fact, that you have to take it as a fact. Is it clear? Why there is a lag? Okay, fine. Okay, fine. Let's start now. Sir, little bit buffering is there. I don't know why this happening. Not from my side, because internet is perfect now. But maybe. Let's start now. Let's start. We have to adjust because new platform is going on. New platform is conducted here. So because of that lag, maybe there's. So let's start now. So this is the example 1 and example number 2. Now let's see here. See, the first function that we are going to cover is a step function. Let's start now. A step function. This is the first example. Step function. Now listen. See, the step function is a function which have a constant jump here. See here. Suppose I have a function. This is the y-axis. Suppose I have a function which is 0 for some value, and then it will suddenly enters a jump here. Suddenly enters a jump here like this, and it will maintain the jump like this. See here, it will maintain the jump here. So it is having a constant jump of a, let's say. And how will you denote this? You will denote this is as a times of ut. A times of ut, where ut denotes the unit step function. Ut denotes the unit step function. Is it clear? Please refresh it. Refresh it, guys. Please refresh it. I don't think that there is a problem in my side. Please refresh from your side also. Okay. So this is a AUT, which is denoted by this one. So A has a jump like this. So how will you define A? This is equal to 0 when t is less than 0 and is 0 and is A actually for t greater than 0, and it is actually, it is the undefined mathematically minded. I will tell you in a signal system. See, listen carefully. I will tell you in signal system there is a jump here, and at the jump the mathematical function itself is not defined. So we will take the average before and after. This is the approximation value, and this is the a by 2 at t is equal to 0. You will see in signal system. See, listen carefully. A by 2, the jump here, at jump, what is the value? It's the average of the value before jump, at this point and at this point. So what is the average? 0 plus a by 2 is the a by 2. This is what the step function is, and you can send the step function anywhere. Means I want to say is that, see here, oh sorry, listen carefully. Okay, so what I want to say is that if you want to let's say, shift the function here. Now you know that, see here, those who have covered signal system, then they know that. If you don't know, then it's okay. Suppose I have a signal like this. Suppose I have any signal, see, whatever, any signal is there, any signal, listen carefully. Any signal, center is 0. This is from minus A to B. Now point is that if you shift the signal here, then you will say that it is a delaying part. You are delaying the signal. If you shift the signal here, then you are advancing. So this is delaying, and that is advancing. This is xt. And what is the format of delaying? See, listen carefully. The format of delaying is that it is x of t minus of alpha. What is the format of advancing? It is a x of t plus alpha. So this, the function when it's delay, if you move towards right, this is what a delay is. If you move towards left, then it is nothing but my what? Advanced version. For example, if I want to plot, let's take it, plot ut minus of 3. Can we plot it? Ut minus of 3? Can we plot ut minus of 3? Come on everyone. Can we plot ut minus 3? Yes, of course sir, we can plot. So we can shift the signal. Tell me, towards right or left? Hello, please tell me, towards right or left? Can we plot this signal ut minus of 3? Of course we can do it. See here, ut minus 3 is a signal which is like this. See, it's a C. That is 3. This is 3. Ut minus of 3 is a signal towards right. Yes or no? Now, what is ut plus 3? 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 Come on, can we see like this? Let's make in this way. See here, ut plus 3 is a signal which is shifted towards left by the factor of minus 3. Don't you think? This is what the ut plus 3 is. Hello everyone. Ut plus 3. That's so. What is the plus sign denoting? That it is advancing. It is advancing by factor of 3. It is advancing by factor of 3. So what I want to say is that, so don't you think that if this is the ut, hello everyone, if this is the ut, then we delay the signal by 3. That's what the minus sign denotes, and we advance the function by minus of 3. Acha, can we add both the functions? Hello everyone, can we add both the functions? Means what I want to say, this is a plot. Example number 1, example number 2 here. Question is that, see, listen carefully. Suppose I want to plot ut plus 3 minus ut minus 3 minus ut minus 3. I will give you only that much basics which is required for my control system, or I will give you only that much of basics that is required for my control system. Believe me please. Is it clear? So 12 hour I will revise whole signal system. So do not expect me that I will give you the essence of that. Believe me guys, on the step itself I devote 3 to 4 hours in signal system class. But that is not required here. Is it clear? We are here for control system. Don't forget this. So whatever I am taking, whatever I am giving here is just take it as a fact. If you don't know, if you know, that's a very well. Now what is the ut plus 3, ut minus 3? So what you have to do is that, let's consider this as a and just consider it as a B. Let's consider it as a B. So what we have to do is that subtract a minus of B. So a minus of B when you subtract, so let's start. So this point is minus 3 and this point is 3. So what I want to say is that, see here, hello, what I want to say is that subtract, see, up to minus 3, somewhere here is a minus 3. Up to minus 3, nothing is there. So 0 minus 0 is 0. From minus 3 to 3, this is 0. That is 1. For example, this is a 1. It is 1. So 1 minus 0 is 1. After 3, it is nothing but my, yes. After 3, 1 minus 1 becomes a 0. So don't you think that I will get a function like this? Minus 3 to 3. So that is what the rect function we have. We have a rect function. We will call this as a rect function having a width of 6. A rect function having a width of 6. But that is not required in our control. What is important is that, see here, this is what the elementary form, and the elementary form can be shifted anywhere. That's what the point is. Elementary form can be added also. Elementary form can be added also. Let's take one more example. Let's take one more example. Suppose I want to write the elementary form of this. Can you write the elementary form? Come on everyone. Can you write the elementary form? Here it is 0, here it is a 2, here it is a 4, here it is a 6, here it is a 2, here it is a 4, here it is a 6. Come on. Can you write the elementary form of this function? Can you write the means in the terms of step? Write in terms of step. Write in terms of step. Come on. Can you write it? See here, how many jumps are there? How many jumps are there? Come on, everyone. How many jumps are there? How many jumps are there? See, I have this jump, I have this jump, I have this jump, and I have this jump. So how many jumps are there? I have 4 jumps. Why buffer? Guys, tell me that whether my voice, audio, video is clear. All clear? Okay, fine, fine. From my side, I think buffer came. That's why I ask you. Tell me whether my audio, video is clear. Okay, fine, fine, fine. Let's see. See here, how many? See, this is the increasing step. Don't you think that is the increasing? See, when you go like this, from here, from here, from here, see here, the arrow that you move is the upward. This arrow is upward. This arrow is upward. And here, arrow is downward. So when arrow is upward, listen carefully, when arrow is upward, this is the increasing step. And when arrow is downward, this means that it is a decreasing step. So how will you write? This is the step starts from at 0 because this is the point jump here. One step starts at here, one step starts at here, and the combined steps will decrease. So this means that, don't you think that is a 2ut, because step starts here, plus 2u t minus of 2 at 2 plus 2u t minus of 4 and minus, see, 2 becomes 4 becomes 6. Now how much a negative jump you have to give? Negative jump how much? 0 minus of 6 means minus 6 u t minus of 6. This is the answer. How many of you got this answer? How many of you got this answer? Come on everyone. How many of you got this answer? How many of you got this answer? Yes, previous slide I will explain again. See here, Vatlingam. See here, what I want to say is that, see this from this, you will have to subtract this one. You will have to subtract this one, na beta. Up to minus 3, both are 0. So 0 minus 0 is 0. From minus 0 to 3, this is 1. Minus 0 to 3 is 1. 1 minus 0 is 1. After 3, what will happen? They all are 1. So 1 minus 1 becomes a 0. So that's why you will get this function. Okay. So that is what this function, this is what the writing means, writing the function in terms of step. Writing the function in terms of step. Now next is that, next is, see here, next is what is the Laplace transform of step? What is Laplace transform of step? Though I will cover the Laplace transform, but just a fundamental. Laplace transform of step function. See here, when you talk about the Laplace transform, means that ut has a Laplace transform of 1 by s. Ut has a Laplace transform of 1 by s. Listen carefully. Ut has a Laplace transform of 1 by s. This means that I have, see here, whatever the denominator roots, whatever the denominators is, how poles, zeros come, that's my topic. You do not have to worry about this. I will devote at least 2 hours on poles and zeros. You do not have to worry. Just fundamental I am checking. So what I want to say is that I will have a single pole at the origin, because at this is s is equal to 0 is the root for this one. So that's what the Laplace transform for 1 by s. Forget about this. Let's talk about another elementary function. Elementary signal number 2. Ramp function. ramp function. Listen carefully. A ramp function. Let's talk about the ramp function. See here, what the ramp functions looks like. I will give you how this originated in signal system, but here simply ramp function is a function which is having the slope like this. A function which is having a slope like this. So a function which is increasing, because ramp is very important, mind it. When the point of steady state error comes, then there is a point known as the velocity error constant. That is what the, because of ramp only. So the ramp is a function which is increasing function like this in the slope manner. So see here, what do you mean by the slope? What do you mean by slope here? Listen carefully. This is, let's say, y-axis. That's what the y-axis is, and that is what the x-axis is. Can you tell me what kind of slope I demand? See here, it is slope is m, which is change in y, change in y, change in y over change in x, over change in x, change in x. Or you will say that m is dy over dx. Or you will say that is also equal to tan of theta. What is the theta? This is what the theta is. So when we talk about the slope here, what is the angle, the theta made by this line on the x-axis? That's what the angle is. Listen carefully. See, what is the meaning of, suppose we have like this. For example, I have a slope of 1. I have a slope of 1. What is the meaning of that? If x moves from 1, y also moves from 1. If x moves for, let's say, 4, if x moves for 4, then y also moves from 4. That's what the meaning of slope 1. How will you interpret slope 2? Come on everyone, can you tell me what is the slope 2? What is the slope 2? Come on guys, what is the slope 2? Can you interpret this one? Can you interpret the slope 2? Hello. Can you interpret the slope 2? Yes, see here. What's the meaning here? The meaning is that when you move 1 here, when you move 1 here, when you move 1 here, is it buffering? Is it buffering, beta? हेलो यार, ऐसी दिक्कत तो नहीं होनी चाहिए यार, क्या हो रहा है मतलब. Hello everyone, please tell me that whether my voice is clear or not. Everyone please tell me. Everyone please tell me. Everyone please tell me there is a voice, if the audio video is clear or not. Just type C. I just want to see. I just want to see. Just type C guys, if everything is clear, so that I start here. These kind of issues if come in the class, then how will I concentrate on studying, teaching? Clear? Guys, those who have a buffering kind of problem, please refresh from your side also, okay? Refresh from your side also, because maybe there is an internet issue from your side. There is a possibility. There is a possibility, na? Let's start. Let's start now. Okay, see here. I told you, guys, Rishi, come from out means completely exit from everything and then come. That is the login again. Login again if you have a buffer problem. Come on, guys. See, what is the meaning of slope 2? What is the meaning of slope 2? Slope 2 means that if we have to move 1 here on the x-axis, then on y-axis we have to move 2. Similarly, if I am moving, let's say 6 here, then tell me, for making a slope 12, how much I have to move on y-axis? Tell me. If I am moving on the x-axis, if I am moving a 6 point here, then on y-axis, tell me how much point I have to move. For 12, for making a slope 12, mind its slope is 12, just a slope is 12. Slope is 2, sorry. Slope is 2. 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 Sorry. Slope is 2. Slope is 2. Slope is 2. Slope is 2. Not 12. Not 12. 12. So 6 2s are 12. The point is y is equal to mx. Point is y is equal to mx. This is the slope we have. This is the slope we have. Y is equal to mx. So what is the ramp function then? See here, what is the standard ramp function that we are going to use here? The ramp function here is nothing but it is t times of ut. T times of ut. So the slope is 1 here. The ideal slope is 1, and that is the reason why I will say that I have a line which is this. I have a line which is this. A line which is having a slope of 1. It is the RT. So here we will see like this, that when I move 1 here, I will have 1 here, I will have 1 here, and I will have 1 here. Similarly, if I move 5 here, then I have to move 5 here, and so on. That's what the meaning here. That's what the meaning. 5, then this is what the 5. So let's talk about RT minus of 3. Can you shift this function? RT minus of 3. Come on everyone. Can you shift this function RT minus of 3? Yes, of course we can make it. Yes, of course we can make it. See, listen carefully. Of course we can make it. RT minus 3 is a function which starts from, come on everyone, which starts from 3. 3. And can you tell me what is the slope of this function? What is the slope of this function? Slope still is 1. Slope still is 1. Slope still is 1. Because the coefficient will denote the slope. So slope still is 1 here. Similarly, can you tell me what is a 5r t plus 2? 5r t plus 2. Come on everyone. 5r t plus 2. Yes, of course we can make. Yes, of course sir, we can make this function. And 5r t plus 2 is a function which is start from, come on everyone, which starts from minus 2 here is a minus 2, and this value is having a plus 5. Yes or no? What is the slope of this function? Mind it that the slope now changes. From 1 to 5. So it starts from minus 2. And the slope is 5. Acha, can you tell me, can you make a line which is having a zero slope line? And can you make a line which is having an infinite slope? Come on everyone. Can you make a line which is having a zero slope and infinite slope? See, Rishi, I want to say that I am defining a function. What I am doing is that I am defining a function. Listen carefully. I am multiplying both the function, which is a t. This is a t. Yt is t. With ut. So when you multiply both the function, na beta, then you will get this function only. This is the standard function. This is the standard function. Rishi. This is the standard function that I am using here. Ha bhai. What is the slope line? Line parallel to 0. See here, listen carefully. I want dy by dx, which is m, is equal to tan theta, to be 0. So for this, come on everyone. For this, the theta has to be equal to 0. Yes or no? The theta has to be equal to 0. This means that I have a line, hello, I have a line. If the line is on the x-axis, or parallel to x-axis, making a 0 angle with nothing but my x-axis, then this means that this is all having the slope equal to 0. All having slope equal to 0. They all having the slope equal to 0, beta. Slope equal to 0, beta. But can you tell me, sir, how will I make a slope equal to infinity? See here, infinity. I want m, which is equal to tan theta, Raja, tan theta, and this is equal to infinity. So that is happens when theta becomes a pi by 2. What is the meaning of that? This means that this line, which is having a slope theta, is now having an angle equal to 90 degree. This means that it is on the y-axis or parallel to y-axis. It is on the y-axis. It is on the y-axis or parallel to y-axis. So all the line which is on the y-axis or parallel to y-axis or parallel to y-axis, they all have infinite slope. They all have infinite slope. You will say infinite slope. You understand my point or not? And you will feel this on this way also. See, m is equal to dy by dx. Come on, everyone. See, change in x is 0, na? There is no change on x, but change in y is there. So if change in x is 0, then dx is equal to 0, m becomes an infinity. Similarly here also. See here, if I say that change in y is 0, dy is equal to 0, this means that m is equal to 0. So that's what the line whenever there is a vertical line, this means that the line which is parallel to y-axis is having an infinity slope. Acha. So this means that, see, listen carefully, if suppose I have this kind of function, listen carefully, suppose I have a function which is having a plus 2 of slope, okay, having a plus 2 of slope up to 0 to 4. Hello. And suppose I make a line further parallel to x-axis like this. So can you write? Can you say that what happened to this line? What happened to this line? Definitely at 4. What I have added? I have added. Come on, everyone. I have added a negative slope of how much? Tell me how much? Negative slope of how much? Can you tell me how much of negative slope I have added at 4? How much of negative slope I have added at 4 so that the line becomes a parallel to x-axis? Tell me, come on, everyone. Please, guys, comment, everyone. Please tell me negative of how much? Negative of how much? Negative of 2 here. So if suppose someone asks you that can you write the elementary form in terms of ramp, then can you write this like that it is a 2RT because it is having a slope of 2RT, and then minus of 2 R of t minus of 4. Come on, everyone. Don't you think that this is the elementary form of this function in terms of ramp? Hello. This is the elementary form in terms of ramp of this function. This is the elementary form of a ramp of this function. Acha. So suppose I continue here. I continue here, and at, let's say, at 8, for example, I have 8. At 8, come on, everyone. At 8, okay, I have to adjust the point also. Yes or no? I have to adjust the, if this has to be, okay, let me take a y-axis here. Y-axis here. So this has to be 8. This has to be 8. Then only 4 to the 8 becomes. Suppose I want a line which stop here. A line which stop here. See here. and having the slope of, let's say I want, this is a 10 or let's say 12, and this is having a -2 slope. Hello, -2 slope. Come on everyone, can you make the elementary form of this function? Tell me, at 8 what happens here? At 8 what happens? Come on, at 8 what happens? At 8, don't you think that I have a negative slope of -2 added here? Come on, negative slope of -2 added here. Come on, negative slope of, this is 4, yes, this is 8. Negative slope of -2 occurs at 8. Come on everyone, hello, 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 hello. -2 slope is added. This is having a 0 slope, mind it that this is 0 slope. On the 0 slope, I have added a -2. Acha, at 12 what will happen? So that negative slope, if no one stops, then it will go down, but I stops here by adding a positive slope here, na? +2. See, come on everyone, if no one stops this line, then the line will continue up to -infinity. Come on everyone, but I have added a +2 slope here to stop at 12. Come on everyone, so don't you think that I can continue this as -2r t minus of 8 and +2r t minus of 12 to make a complete trapezoid, which is this. Come on everyone, which is this, which is whole this. Hello, tell me, hello everyone, I required a 4 ramp to make a 1 trapezoid. Come on everyone, I required a 4 ramp to make a 1 trapezoid. सब कोई बोलेंगे please, everyone must comment, yes or no? Acha, can you write the elementary form of this function then? Can you write the elementary form of this function? Come on, can you write the elementary form of this function? Very simple. So this is -4, this is 4, and that is 24. Come on, can you write the elementary form of this function? Hello, 24. What's the elementary form of this function? Can you write in terms of ramp? Yes, see, at what at t is equal to 4, +2 is added on this signal, na beta. +2 already we have. See, if no one stops, who is asking? Sharan, beta Sharan, listen. See, if no one stops this line, then the line will go like this, na? Sharan, tell me. If no one stops this line, then the line will go like this, na? By adding -4 slope, I stop the line at the point 4, na? At the point 4, if I add -2 line, then the line becomes a x-axis, the line parallel to x-axis. Earlier it has a +2 slope, but by adding a -2 slope, what will happen? It is having a 0 slope. Then a negative line and a positive line. Negative line will make this line to negative, and positive line will again stop it. Here, what's the answer? Sir, first of all we have to, hello everyone, first of all we have to write the slope. What is the slope of this function? What is the slope of this function? Can you write the slope of this function? Yes sir, change in x is 4 and change in y is 24. So m is 24 by 4, it is 6. Hello. And so how will you decide that this is a +6 or -6? If a line is going towards +infinity, it is having a +6 slope. So here also change in x is 4 only. So this means that this is having a slope of -6. This is having a slope of -6. Come on everyone, hello, please try to understand it. Slope of -6. Yes or no? Now tell me what happens. See, this is a +6 slope line, but suddenly at 0, what will happen? This +6 becomes a -6, guys. Hello. This +6 becomes a -6. This +6 becomes a -6. Come on. Earlier it was a +6 line starting from -4. This means that 6RT plus 4. If no one stops, then it will go up to infinity. If no one stops, it will go up to infinity. If you want to make it to -6 at 0, then tell me what should I add? What should I add on that? What should I add on that? On 6, what should I add so that you will get a -6? On 6, what should I add so that I will get a -6? Definitely I will add -12, yes or no? At 0, that's why RT. Come on everyone. Yes or no? -12. Now, tell me what is the effective slope of this? What is the effective slope? Effective slope is -6, na beta. Effective slope is -6. But now at the 4, it becomes a 0. So tell me, what should I add on 4? What should I add on 4 to make it 0? Make it 0. What should I add at 4? At 4 I am asking. At 4 I am asking. Tell me what should I add? So it is a +6. +6 R T minus 4. That's what my xt is. Come on everyone. Hello. Hello. Just type C if this concept is clear to you. Though that's a signal system concept. Signal system you will see in a very detailed manner. You do not have to worry about this. Just type C if you understand this concept. You understand this concept. Just type C. Just type C. You do not have to worry about this. This kind of fact is required. Okay, fine. So that is what the ramp is. That is what the ramp, how ramps look like, how ramps comes, and what are the combinations from that we can make the signals. These kind of things we have. Now next is that what is the Laplace transform of ramp? What is the Laplace transform? Laplace transform. Laplace transform. Laplace transform of ramp. See, the Laplace transform of ramp RT, which is TUT, is 1 by S square. 1 by S square. And hence, we have how many poles we have? I have a 2 poles at the origin. A 2 poles at the origin. So I have 2 poles at the origin. 1 by S square it is, and I have a 2 poles at the origin. What are the poles? What are the zeros? We will see in the Laplace transform. You do not have to worry. 12 hours I have to take a basics. So everything will come. You do not have to just go get panic if you don't understand the terms. You don't have to worry about it. Just simple general knowledge I am using. So this is the second elementary form. 2 poles in the elementary signal. What is 22? Okay, fine. Third signal. Third signal is a parabolic signal. I just give you a concept and Laplace transform. Parabolic signal. And how it look like? See here, the general format here is xt is equal to k into t square. Listen carefully. K into t square. The parabolic signal is k into t square, where k we take as a square by 2. A square by 2 into t square. And you know that what's kt square looks like. Sir, you know that kt square look like this. Look like this. That's what the slope is. That's what the slope, which is k. And k here I am taking it to be a square by 2. And what is the Laplace transform of that? What is the Laplace transform of that? In general, listen carefully. T to the power of n minus 1 upon factorial n minus 1 ut has a Laplace transform of, this is ut, has a Laplace transform of 1 by s to the power n. Fact, again a fact, where it comes, yes, ut. ut comes ut. Where it comes, hello everyone, where it comes, यार क्या हो रहा है, ये बफर क्यों हो रहा है? Hello everyone, hello, 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 hello. Hello, everything is clear? Everything is clear? Clear? हाँ, no issues. अच्छा, sir, if suppose I want a t square, this means that I put, how you will get t square here? When you put n is equal to 3, when you put n is equal to 3, I don't know, again see, look, video is still lagging. Oh yeah. Hello, all clear? ओ भैया क्लियर है क्या? Is it clear? Is it clear? Everyone, please comment here. I don't know what happened in my side, your side. अच्छा ठीक है, चलो, it's okay. See, listen carefully. See, a parabolic signal. Okay, fine. A parabolic signal. Listen carefully. Starting from here. Here, a parabolic signal, beta, is represented by kt square. A general parabola. See, listen carefully. A general parabola can be represented by, general parabola can be represented by a general parabola. General parabola can be represented by this fact: xt is equal to kt square. And how it look like? You know that how it look like, yes or no? It is this now function. This kind of function we have. This kind of functions we have. This is the parabola. This is a parabolic curve. This is the parabolic curve. ऐसा parabolic curve ना. Okay, fine. अभी clear है ना? अभी देख लो बेटा. हाँ. Maybe listen carefully here. Is it clear? Please देख लो. Sir, this is a parabolic function. Yes or no? जिसका भी बफर हो रहा है, please, those who having a buffering problem, please refresh it. This is the parabolic function. And suppose if I want to restrict only on the first quadrant, suppose I want to restrict beta in first quadrant, then what should I do? I should multiply it with ut na beta. If I multiply it with the ut, then don't you think that I will get this kind of function? Beta bolo, I will get this kind of function. Hello, I will get this kind of function. That's what? This is a k into t square into ut. Hello, k into t square into ut. K into t square into ut. K into t square into ut. This is what the parabolic function that we are going to start, that we are going to use in our course. So k t square ut is a parabolic function. Now listen carefully. Now what I told you next is that suppose if I have t to the power n minus 1 upon factorial n minus 1 ut, then the Laplace transform is 1 upon s to the power n. So suppose I want a t square here. This means that put n is equal to 3. When you put n is equal to 3, what you will get? What you will get is that t to the power square upon square has a Laplace transform of 1 by s cube. Come on everyone. Just put n is equal to 3 here. Just put here to make t square here. Put n is equal to 3. 3 minus 1 becomes a 2. 3 minus 1 becomes 2. Upon factorial, and factorial 2 is 2. Ut into ut, of course, will have a Laplace transform 1 by s cube. So suppose if you want to multiply k here, then the same k will be multiplied here also. The same k will be multiplied here also. Hello? So k t square by 2 ut will have a Laplace transform of k by s cube. K by s cube. So tell me, find the Laplace transform of, find Laplace transform of 6t square ut. Can you tell me what is the Laplace transform of 6t square ut? Come on everyone. 6t square ut. What is the Laplace transform of 6t square ut? Come on everyone. 6t square ut. What is the Laplace transform? 6t square ut. What is the Laplace transform? Come on everyone. Can you tell me what it is? 6t square ut. Hello? No, beta. What I told you, just told you. What I just told you. Oh bhaiya, what I just told you. K t square by 2 ut has a Laplace transform of k by s cube. K t square by 2 ut has a Laplace transform of k by s cube. K t square by 2 ut has a Laplace transform of k by s cube. This means that what? K t square by 2 ut has a Laplace transform of k by s cube. Oh bhaiya, this means that, listen carefully, I just want a k by 2 here. K by 2 equal to how much? 6. K by 2 equal to how much? 6. This means that k is equal to how much beta? 12. So what is the Laplace transform here? Is a 12 by s cube beta. 12 by s cube. Hello? Hello? Yes or no? Yes or no? Come on everyone. K t square by 2 ut has a Laplace transform of k by s cube. So this means that k by 2 is equal to 6. This means that k is equal to 12. Not a 6 by s cube. Nahi, 12 by s cube. Okay. So tell me 4 by 3 t square ut. What is the Laplace transform? What is the Laplace transform? Problem number 2. Tell me, what's the Laplace transform? 4 by 3 t square by 2 ut has a Laplace transform of, tell me, 4 by 3 t square by t square ut has a Laplace transform of how much? Whole k. This is what? K by 2. Compare it with k by 2. Compare it with k by 2. Compare it with k by 2. Oh bhaiya, please compare it with this. Compare it with k by 2. It's a k by 2, na? It's a k by 2. Then has a k by s cube. So k by 2 is equal to how much? 4 by 3. This means that k is equal to how much? 8 by 3. So this means that this 4 by 3 t square ut is how much? 8 by 3 s cube. You understand? 8 by 3 s cube. Hello, plus, why you are giving 4 by s cube as answer? 8 by 3 s cube. 8 by 3 s cube is a general format. Okay, fine. Okay, fine. So that's what the parabolic function is, and elementary form of this one is. Now let's talk about the next elementary form, which is a very, very important. Fourth elementary form is impulse function. Impulse function. Listen carefully. Impulse function. and some properties of impulse that is required in my course, though it is not required in control system, but I will give you some property of impulse. See here, whatever I am that is giving you about the impulse, take it as a fact, because impulse is a very broad topic in signal system. So everything that I am giving here is just a part of signal system, and take it as a fact. You do not have to worry about that how it comes. It will comes in front of you when signal will come into the picture. See here, impulse function is a function which is having, see, look at that, how it comes is that, suppose I have a rector function like this. Suppose I have this kind of function. Listen carefully. Suppose I have a function which is having a minus tau by 2, and this is having a height of 1 by tau. Listen carefully. What I want to say is that, suppose I have, this is a rector function, just we have covered the rector function. See, this is the rector function. Now what I am doing is that, look at the width of this rect. The width of this rect is tau. This is tau. Width is tau. And what is the height? Height of this rect is 1 by tau. Height of this width is 1 by tau. So that area which is width into height is unity. So that area which is width into height is unity. Now listen carefully. What I am doing is that I am decreasing the width and increasing the height in such a way that my area under the curve remains a constant. What I want to say is that, see, listen carefully. What I am doing is, see here, I am decreasing the width of the function and increasing the height of the function in such a way that the area, say this, for example, this becomes a minus tau dash by 2 to tau dash by 2, and hence this is 1 by tau dash. So on. This is nothing but my, like this, and so on, and so on. One more. Now tell me guys, in the limit tau tending towards 0, don't you think, hello, in the limit, what is the area? This is equal to 1 by tau multiplied by tau. In the limit tau tending towards 0, don't you think that the width will simply approaching towards 0, but height will approaching towards, not equal to, mind it, because infinity into 0 is an indeterminate form. We are approaching towards, we are not making it 0. So what I am doing is that in the limit tau tending towards 0, the width is ideally approaching towards infinity, 0, and height is approaching towards infinity, so that the area under the curve becomes a finite. Hello, area under the curve becomes a finite. So when you put tau tending towards 0, you have a function which exists only for a very less width, but having a very high amplitude approaching towards infinitive. But one thing is common, that is the area under the curve is finite. That function in signal system is denoted as an impulse function, which exists only for momentarily amount of time, but has a very high and nothing but my weight, very high weight, you will say. Very high weight means the amplitude of this function is tending towards infinitive, so that its area under the curve remains a constant. So what I want to say is that impulse function is denoted by delta t, and what is delta t? Ideally, delta t is ideally infinity, which is exists at t is equal to 0, and 0 else. And how will you represent it mathematically? It's a minus infinitive to infinitive delta t dt, and this is equal to, it is equal to 1. So what is the impulse area in the curve? This is equal to 1. See, area in the impulse function is equal to 1. But mind it that impulse is a function which is not decided by its value. The value ideally is infinity. Impulse is a function which is not decided by its value. It is decided by its area under the curve. So when we talk about delta t, then we will say that delta t is equal to 1 at t is equal to 0. Mind it that this 1 is nothing but my area under the curve. Area under the curve. And is 0 else. And is 0 else. 0 else. And minus inverted to inverted delta t dt still is equal to 1. So whenever you have, see here, in step function, we have an information in terms of jump. Step function, we had just covered. In ramp function, we have an information in terms of slope. In jump function, in this kind of function, we have an information in terms of area. So area on the curve is finite. Area on the curve is finite. And we represent our impulses in terms of this function. This is what the actual definition of an impulse function is. This is what the actual definition we use in our signal system, like that. Now this we call it to be unit impulse function. This is what the unit impulse function is. Unit impulse function is. Impulse function is. And sir, in control system we will use unit impulse, but we also use a non-unit impulse. Means, for example, impulse of, let's say, k. Let's say I have 5 delta t. How will you represent the 5 delta t? What is the meaning of that? What is the meaning of 5 delta t? It is saying that, see here, it is saying that at t is equal to 0, you have a strength of a function which is denoting by a spike, and this is having the strength equal to 5. This at t is equal to 0. So what you will say, that it is equal to 5 at t is equal to 0. But mind it that this 5 is not its value. The 5 is not its value. 5 is not its value, but 5 is the area under the curve of the function. 5 is the area under the curve of this function. And moreover, that is 0 else. 0 else. So minus inverted to inverted 5 delta t dt is equal to 5. So that is also a one representation of nothing but my impulse. Hello everyone. Is this point is clear to you? Come on everyone. Is this point is clear? Everyone must comment. This is the fundamental. I hope you have this kind of fundamental in your curriculum. And this is just a fundamental that I am revising thoroughly. Control system not yet started. Control system will start. But mind it that this kind of things is very, very important. Now question is that, sir, can you make a shifted impulse function? So what is delta of t minus of 3? Yes, of course I can make. Of course I can make. So I have an impulse function which starts not from 0 but from 3, and hence this is what the impulse is. At t is equal to 0, that's at t is equal to 3, this is what the 1. Strength of 1. Next is what is delta of t plus 4? Easily we can make plot. Easily we can make a plot. See here, what kind of plot we have? Listen carefully. What kind of plot we have? So at minus 4, somewhere here, at minus 4, we have this. Is it clear? Now let's talk about some few properties of impulse which is required in my course. So every property, each and every property, believe me, I will explain. If I teach you signal system, I will derive it rigorously in front of you. But since it is a control system class, not a signal system class, so I will just give you property. Please mug it and revise it as maximum as possible. Listen carefully. See here, some property, few properties of impulses. One property is which property is property of impulse, which is required in my course. Property of impulse. First property is a product property. What it says, suppose I have x of t, and if I multiply it with an impulse delta t, then it is same as it is x0 into delta t. So where the impulse is at 0, put t is equal to 0 here. This becomes the area of the function delta t. Suppose if I have x of t multiplied with delta t minus of alpha. What is the result? Tell me, can you tell me, anyone tell me what is the result? See where the impulse is at alpha na? So put alpha here. What you will get? You will get x of alpha delta t minus of alpha. X of alpha delta t, mind it that this is the product, so impulse has to be there. Only impulse height, which was earlier 1, is now changed to x of alpha. Same here, see. This is x of t multiplied with delta t plus alpha, that is equal to x of minus alpha delta t plus alpha. Why? Because impulse exists at minus alpha. Impulse exists at minus alpha. Impulse exists at minus alpha. Point number 1. This is the property number 1. This is the property number 1. Property number 1. Property number 2 is area property, which is one of the most important property. Area property. And what it says, if you take the area in the curve of this function, means minus inverted to infinitive x of t delta t dt, then the result is x0. Then the result is x0. If you have minus inverted to infinitive x of t multiplied with delta t minus of alpha dt, then the result is x of alpha. See, it comes from here. If you take the area in the curve of these delta t minus alpha, delta t plus alpha, I just teach you that they are equal to 1. So what you left with? x0, x alpha and x minus alpha. Same here also. Minus inverted to infinitive x of t delta t plus of alpha times of dt is x of minus alpha. X of minus of alpha. X of minus of alpha. So this is the two property which you have to use in your course very rigorously. For example, let's talk about the one problem based on that. See here, one problem based on that. Sir, suppose I have x of t. Suppose I have x of t, which is 5t square plus 4t plus 3. Tell me what is A? What is, find what is xt into delta t? B, what is xt into delta t minus of 3? And C, minus inverted to infinitive x of t into delta t minus 4 dt. Come on, make it fast. 3 is right, not the answer, Hiteshi. Come on everyone, jaldi se bolenge sab koi. Everyone must comment. Come on everyone, what is the first answer? What we have to do? xt into delta t. What is the xt into delta t? What is the xt into delta t? Come on everyone. What is xt into delta t? I just told you what is the xt into delta t. Is the x0 into delta t. Come on. x0 into delta t. The delta t you have to assume. Come on everyone. How much it is? Put t is equal to 0. Put t is equal to 0. Put t is equal to 0. So what you will get? You will get as 3 delta t, mind it. 3 delta t. Not 3. 3 is not the answer. Sir, suppose if you take the area in the curve, then answer is 3. Okay. Then area in the curve, then answer is 3. What about this one? So where the impulse is? Come on, where the impulse is? Where the impulse is? Where the impulse is? Where the impulse is? Impulse exists at 3. Put t is equal to 3 here. So what you will get? 5 into 9, 45. 45 into 12. 45 plus 12. 57. 45. 57, 60. 60 delta t minus 3. Check it. 60 delta t minus 3. 60 delta t minus 3. I think so. This is the answer. This is the answer. 60 delta t minus of 3. Acha, what about this one? So we have to put t is equal to 4 directly and no delta at all. What's the answer? So it is a 4, 16, 5 80, 80 and 4, 16. 80 plus 16 is 96, 99. 99 is the answer. Next answer is 99. Come on everyone. Next answer is 99. 99 is the answer. Acha. Acha. Sir, what is B? D, na? What is minus infinity to infinitive x of t into delta 2t plus 10? Can you tell me? What's the answer? Delta 2t plus 10. Delta 2t plus 10. Hello. What is minus infinity to infinitive x of t delta 2t plus 10? Delta 2t plus 10. See here. Just one more property on that. First property, second property. Third is scaling property. Third is scaling property. Scaling property. Property. Delta of alpha t is 1 by mod alpha delta t. 1 by mod alpha delta t. So what it is? Just minus infinity to infinitive x of t. Take t as a common, delta 2 common. It is a t plus 5 and this is dt. So put t is equal to 2 here. 1 by mod 2 you will get. 1 by mod 2 you will get, and it is minus infinity to infinitive x of t delta t plus 5 dt. Delta t plus 5 dt. So 1 by 2 common. 2 put 2 common. 2 comes outside. That's what the scaling property is. Delta of alpha t is 1 by mod alpha delta t. So what it is? Nothing but my put t is equal to minus 5 here. So it is 1 by 2 into what? Plus 4 into minus 5 plus 3. I think 25. 125. 125 minus 20. 125, 105, 102. I think so. It is a 102 by 2. ये आएगा शायद. चेक करना प्लीज. ये आएगा ना भाई. 125 minus 20. 105. 105 minus 3. 108 it is. Plus है. So 54 is the answer. I think so. 54. 54. Yes, 54 is the answer. Hello. Hello, hello, hello. How many of you got this properties? How many of you got this property? Come on, everyone. How many of you got this property? That's enough basics I required for signal point of view. Signal point of view, that's enough basics I required. Just type C if you got all the 4 elementary signals. Just type C if you got all the 4 elementary signals. Okay? Yeah. Next is that basics of classification of system. Basics of classification of system. See here, in the last class I told you that what do you mean by the word system? What do you mean by the word system? System is a meaningful interconnection of devices which process input and produces output, and in this whole process the conservation of energy is preserved. Listen carefully. So if suppose if I have a system, like for example, if I have a system, listen carefully. If I have a system, I have one input here, and I have a one output here. Listen, one output here. Let me call this as an input xt, and let me call this as an output y of t. This I am calling it to be system. This I am calling it to be system. Now listen carefully. How will you handle the system? System can be handled by two ways. Two ways are there to handle the system. One way is that there must be some input-output relationship. There must be some input-output relationship between system or system mathematical response is defined. This is another way. One way is that there must be input output relationship between input output relationship in system, and second is that system mathematical description is defined. Mathematical description is defined. Listen carefully. What is the meaning of that? The meaning is that, so there is a input, either you have an input output relationship or you have a mathematical relationship defined for a system. For example, let's consider example. Suppose I may have yt as d by dt of x of t. Now you know that d by dt of xt. What is the meaning here? See, whatever the input comes, system will take the differentiation part and gives as an output. Let's take another example. Second example. So yt is x of t minus of 3. So whenever the input comes, system will delay the input by factor of 3. That's the input output relationship. Third, so system yt is nothing but my let's say x t into cos 2t. So system will takes the input multiplied by cos and you will get the answer. Fourth example, yt is equal to, let's say, x square of t. So system will take the input and then square it and you will get the answer. Fifth example, yt is minus infinity to t x tau d tau. See, what is the job of the system? It will take the input xt. First it will take the input xt. It will change the domain to x tau. This is x tau. Now it becomes x tau. X tau, variable change. Variable change will not change the definition. It's just a simple signal. And now it is integrating from minus infinity to t. So whatever the value of t is decided by this limit. The limit is variable here. So depending on the limit of t, it will give you the answer. That's what the meaning of this is known as a running integration. This we will see this in signal system. You do not have to worry about this. Running integration and many other. See, let's take a sixth example. Yt is equal to e to the power xt. E to the power xt. So this is the another example. Can you tell me how many possible examples are there? As long as input output relationship is concerned, in how many ways I can write the input output relationship? Tell me, how many possible ways are there to write the input output relationship? Come on everyone. How many possible ways are there to write the input output relationship of this simple function xt and yt? Infinite ways, yes or no? Infinite ways. Come on everyone. There's an infinite mathematical relationship possible. Infinite mathematical ways are possible to relate input with output. Infinite ways are possible. Infinite ways are possible to relate input with output. So that is the reason why we enters into the second part. That is nothing but we can define the system mathematical description. We can define a system mathematical description which is denoted by h of t. mind it that, which is denoted by h of t. H of t, we call it as impulse response of a system. Impulse response, response of a system. That is very, very important. And it is just a mathematical description of a system. So for example, if impulse response, I am talking about e to power minus of 3t ut, e to power minus of 3t, let's say. So you know that e to power minus 3t graph is like this. See here, this is what the e to power minus 3t graph is. And now you are multiplying with ut. This means that this part will be neglected and only we have a positive part. So what I want to say is that, listen carefully, this is the one example where impulse response is defined in this way. We call this as the impulse. Why we call this impulse response? Because we enters the impulse into it to get the system response equal to this. You will see in signal system. But mind it that impulse response is not defined for every systems. What we actually do is that, based on the input-output classification, we classify our system. We classify our system into 6 basic category. One is, that is static and dynamic system. Second classification is that it is causal and non-causal system. Third is that it is linear and non-linear system. Fourth classification is that it is time variant and time invariant system. Fifth classification is that it is stable and unstable system. That's the only classification we need in control system. Unstable system. See here, we define our system under 5 basic category. One more category is there which is required in signal system, not in control system. As the invertible, non-invertible system. We will see this in signal system, but in control system only I have to deal with this one. In control system, believe me, in control system we only talk about linear time invariant system, LTI system. But what is linear, what is non-linear, what is time variant, time invariant, we must know. That we will see. But the point is that in our control system we mainly talk about linear time, and control system by default are causal in nature. Causal means physically realizable. But what do you mean by causal? What do you mean by non-causal? That's my topic. That's simple. But the point is that, see here, in our control system, by default, this condition has to be satisfied. This condition has to be satisfied. This condition has to be satisfied. Satisfied what? It should be linear, it should be time invariant. If you violate this condition, then one approach which is known as transfer function approach is not defined then. Mind it that 95% of course is valid on transfer function approach, that is Laplace transform of output upon Laplace transform of input with all initial condition subjected to 0. That is only possible when the system is linear and time invariant, and that is the case why HT is defined for such system. Impulse response of a system is only defined when the system follows a very simple condition which is known as linear time invariant. LTI By default, my system is causal. Causal means control system means they are physically realizable. For example, AC is physically realizable, fan is physically realizable, aircraft is physically realizable. All the systems which are physically realizable, I will take only that system. Also, all the systems which are either static or dynamic, that depends actually. Either some examples are for dynamic one, some example for static one, but dynamic examples are only those systems which are nothing but my causal in nature. So dynamic system is defined in my control system, but they are only defined for causal in nature. And then principal objective comes into the picture. If system follows all these four categories, my whole design is only centered around the fact that I want to make the system to be stable one. If I follow all such conditions 1 2 3 4, then the simple objective in my whole course is to nothing but to make the system to be stable one. But what is this kind of stability means? What kind of stability, sir, you want? That is the reason why I will devote, that is at least 2 to 3 hours on this topic. That is what do you mean by static system? What do you mean by dynamic system? What kind of dynamicity I want in my system? What is causal, non-causal, anti-causal? What do you mean by linear, non-linear? What do you mean by time variant, time invariant? What do you mean by stable, unstable? Means what kind of stability you actually want? Someone says that BIBO stability. Okay, fine. Sir, what do you mean by BIBO stability, sir? What do you mean by BIBO stability? Is BIBO stability guarantees any kind of stability? That is a question. That is a question. And then when we enters into the Laplace transform, then I will relate the BIBO stability with nothing but my S-plane stability. And then you come to know that yes, for stability, what my objective is to make all the pole in the left half of S-plane. That you will come to know. Is it clear? So that is the reason why this topic is very, very important, guys. Very, very important. Very, very important. Because without this, you will mug it. See, the fundamental objective is to be very, very clear that what kind of system you are going to deal in your control system. So if your objective is very, very clear, then only you will design a system in terms of guys, please listen here. You will design a system in terms of nothing but Nyquist, Routh-Hurwitz, root locus, and so on. So that is the reason why I devote at least 12 hours on fundamentals. If this fundamental is clear, basics is clear, what is transfer function? Why transfer function says that all the initial condition has to be equal to 0. These kind of things, if it is clear to you, then only the whole course will be very, very beneficial. Is this point to you? Is this point is clear to you, guys? Is this point? We must know all these 5 categories. We must know all these 5 categories. Then only our lives becomes very easy. Hello. Is it clear? But without that, it's not possible. Without that's not possible. You will mug control system. You will mug it. It's okay, fine. You will mug it that all the pole has to be in the left of S-plane. But if someone asks you one very simple question, you will be clean bold. Surely clean bold. Because you will not able to explain or justify why if pole is in right half, then the system has to be. What's the concept of reason of convergence? These kind of things has to become. Why everything comes from signal system? Mind it that signal system is a father, control system is just an application. Control system is just the application of signal system. Everything roots comes from signal system. So you must know this subject before handling this subject. Many of you don't know. That's why I am giving you basics. That's why I am giving you fundamental for 12 hours, 13 hours. Is it clear to you? So this is what the classified. Now the classification part, just write it. Classification part, whatever we have covered, just see, I have make a clear cut notes. Just makes your notes like this only. Like this only. You don't have to write in the class. I will make a very clear notes in front of you. Very, very clear notes. Is it clear? And each page note, if you just simply copy now, you will understand everything. You will understand everything. Is it clear to you? Just concentrate on just focus on studying everything. that is gaining everything. If you want to write now, then I will dictate you whatever the points I'm not able to write here in the, that's the paragraph form. That paragraph I will dictate, surely I will dictate. Just leave 1 or 2 pages for that. But believe me, don't waste your time on making the notes. Just copy these notes and simply revise it as maximum as possible. That's very beneficial for you. Is it clear? I will write a clear-cut note so that everything has to be cleared. Just your part is for understanding. You do not have to waste your time on nothing but by making notes and that is decorating it. It's really not possible. Is it clear? So because GATE is just behind you, 3 months after you will have a GATE examination. October, November, December, January, don't count please. Because January is for revision. Is it clear? After 3 months, definitely GATE will come. So don't waste your time here. Just simply what I'm telling you, just copy it, revise it as maximum as possible in your phone itself. You have a PDF in your phone itself, just revise it, and whatever the device you have, and simply that is whatever the problem I'm giving you in terms of DBP or in terms of homeworks, just go through it. Is it clear? And try to solve the problem. And please enter us into that Telegram group. That's very, very important, because in Telegram group, very serious students are there. Okay, so you have to fight with these students also. Pankaj Sir PW, just search and you will that is enter into that Telegram group. And then after that, I will provide you notes here there also. And whatever I have teach you from tomorrow onwards, we will start the classification of systems. From classification of systems. So what we have covered till now, we have covered a revision on signals, and we have just started on signal, and we have just started the classification of system. We will cover this subject, we will cover this topic, sorry, in tomorrow class of system. But hold on, I want to ask some few things from you guys. What about my pace? Is my pace is okay to you, or shall I have to slow it or fast it, whatever? Yeah, ये मेरे हाथ में थोड़ी ना है. Buffering issue is not in my hand, guys. I don't know my side. If you want to check, I will tell you. So I have a speed of 200 Mbps. I don't know why buffering came. Guys, tell me about my pace. Shall I have to increase the pace? Shall I have to increase the pace? Is it okay? Okay, fine. So don't worry about the subject. Just leave the subject in my shoulder. Just leave the subject in my shoulder. Just attend the class daily and do the homework as maximum as possible. Today I am not giving a homework for 4 to 5 class. I am just making our environment to be very compliant so that everything has to be there. Is it clear? So you don't have to worry about the problems and DBP. Problem DBP will come. I will solve nearly 600 problems in your control system. You don't have to worry about this. More than that, not less than that. Is it clear? So you do not have to worry about. Is it clear to you? Yes. Conceptual understanding is very important. That's why I am trying on that. Is it clear to you? Yeah. So thank you very much, guys. Let's call for the day. From tomorrow onwards, miss, tomorrow is I think same I think timing 8:30 to 10:30. But next class onwards, the timing is from on morning, and 2 sessions are there. Not 1 session, 2 sessions are there. Is it clear? 8:30 to 10:30, and then 11 to 1. So thank you very much. Thank you for the day. Thank you. Yes, of course, you need to copy if you want. If you don't want, just take it. Pawan, you don't have to copy from my point of view. If you want to copy, then you can. Bye bye.